Securing DNS servers. The Domain Name System, or DNS, is a method of resolving IP addresses to English-sounding names. In Windows 2008, a DNS server is a required service that's used by clients and servers to access Active Directory. Since practically everything in your network is built upon the premise that DNS is available and working and reliable, it stands to reason that special attention should be given to ensure that it's also very secure. So in this video, we'll be looking at ways that you can secure your DNS server so that it remains up and viable. Now that Windows Server 2008 is out and available, it does bring with it a couple of nice additions which can affect our DNS servers for the greater good. Firstly, we can now build read-only domain controllers, which are, as the name suggests, domain controllers that are read-only. These new types of domain controllers are Windows 2008 only features, and they're really useful since they're really designed to be deployed at locations where physical security is potentially weak, such as at a branch office or even in your DMZ, or where you might have a novice administrator at a remote site and you don't want them making changes that might affect your other domain controllers in your network. Now, since we have a whole video dedicated to read-only domain controllers, we're not going to cover them here, but remember that DNS and Active Directory domain controllers go hand in hand. And from a DNS security point of view, you can't go past throwing a few read-only domain controllers into your network because the server will store read-only copies of primary zones and not writable ones. So any changes to DNS will need to be performed on a writable domain controller, which will be presumably in a more physically secure location. Also, since Windows 2008 supports running a DNS server using a server core build, for a much reduced attack surface, you should consider doing away with the GUI and learning how to type. That way, only the services required for running DNS will be running, and you'll get better performance and less risk. Now, DNS on Windows 2008 also supports configuring Active Directory integrated zones. When we choose to integrate DNS within Active Directory, this means that rather than our DNS server storing our DNS records as plain text files, DNS is now stored within the Active Directory database as objects and replicated as part of domain replication. So if we click on Start and we go to Administrative Tools and launch the DNS console, and then we'll expand our server here, DCO1, and then we'll expand forward lookup zones. And if we right click on our winstructorlab.com zone and choose Properties, on the General tab here, we can see that we're currently set to the preferred Active Directory integrated mode. So DNS is now stored within the Active Directory database as objects and replicated as part of domain replication. Now, if you do currently have your DNS server configured to not be integrated with Active Directory, we only need to click on the Change button here and then check this box at the bottom. But don't forget that in order to integrate DNS with Active Directory, you will need to have your DNS role installed on your domain controller. It can't be separate. Secure Dynamic Updates is another setting that we can use to further mitigate risk to our DNS server. Dynamic Updates by itself means that the DNS client, or in other words your workstation, is responsible for updating the DNS server, which reduces the amount of administration required. But by itself, this can cause problems since rogue DNS clients can flood the DNS server with bogus DNS entries. However, when we choose to use secure dynamic updates, we can mitigate this risk by first requiring that the DNS client is a member of our domain. Now, if they aren't a domain member, then they can't update DNS. Now, if you are in a high security environment, you'll probably want to go one step further and enable only secure updates on all of your DNS zones except your top level and root zones, and then set those zones to not allow dynamic updates at all. Now let's go and click on the Zone Transfers tab, since this used to be a problematic area, especially back in Windows 2000, since zone transfer would be allowed to any server, and that was a problem. At least in Windows 2008, zone transfers, as you can see, are not enabled by default, and you'll need to turn them on. Now, when you choose to configure zone transfers, you should configure them to only either selected servers, which you can list here, or to only servers listed on the Name Servers tab. Now, the next thing you should also give some consideration to is whether you need to have recursion enabled or not. So we'll go and cancel this, and we'll right click on our server DC01 and choose Properties, and then the Advanced tab. And here, by default, you can see that recursion is enabled for the DNS Server service. Recursion is when Windows 2008 DNS servers query other servers on behalf of the requesting client, attempting to fully resolve the name by contacting all of the DNS servers it can in turn to find out the answer. In contrast, the root servers use an iterative response, which basically says, go and ask that server over there for the answer, as I'm not going to do it for you. Recursive lookups continue until the server receives an authoritative answer for the queried name, and then the server will forward this answer in a response to the original query from the requesting client. Now, this means that attackers can use recursion to perform distributed denial of service attacks on their targets by sending a DNS request to your DNS server, which will go and find the host requested and send it back to the client that requested it, which of course really came from a spoofed return address which points to the victim's machine. Now, this means that your DNS server is actually actively participating in the attack. Certainly something you probably want to avoid getting involved in. So if you don't really need to have recursion enabled, then go ahead and disable it. Now, also on this same Advanced tab down the bottom here, we can ignore non-authoritative resource records by leaving this Secure Cache Against Pollution box checked. This prevents attackers from polluting the DNS server cache with resource records that haven't been requested by our DNS server, and if our DNS server discovers that referred names are insecure or potentially bogus, it's going to throw them away. Now, if this option is left enabled, then the DNS server will check the response that's been given in a referral to see if it came from the same DNS name which the request was for. So for example, if our DNS server here sent out a request for the web server at google.com and the response comes back as something outside that domain tree, such as the web server from microsoft.com, then our DNS server is not going to cache the response. Now, the next tab we should consider here is the Root Hints tab, and this tab by default contains the 13 IP addresses of the root servers, and it's populated when we first install our DNS server. Now, normally you'll leave these as they are, you probably won't touch them, but if you happen to be running a private internal DNS namespace, then you'll want to configure these to point to your own internal DNS servers that host your internal root domain. That way, your internal DNS server won't send your private information out to the internet when they resolve names. Now, speaking of internal DNS servers, another recommendation is to configure your internal DNS servers to communicate with your external DNS servers in your DMZ, and only configure the external DNS servers with root hints that point to the real root DNS servers out on the internet. Now, I should also mention, like we discussed in an earlier video, you could also run the security configuration wizard over your DNS server to lock it down even further so that any unnecessary services are disabled, and this is going to reduce the vulnerability of your server to any attack. Alright, well, the final thing that I want to cover in this video is something called the Global Query Blocklist, and it's a new feature to Windows 2008. When you allow dynamic DNS updates to occur, we're allowing DNS client computers like your workstations to register and dynamically update their resource records whenever a client changes its IP address or host name. Now, obviously this has the benefit of requiring almost zero administration, since the client will update DNS automatically, and this is especially useful when clients' IP addresses change frequently, such as when they're using a DHCP server to obtain their IP addresses. The problem is that these dynamic DNS updates can fall prey to a situation where an authorized client can register any host name they like, even those that are normally reserved for specific applications. And two of these commonly used protocols are listed here: the Web Proxy Automatic Discovery Protocol and the Intra-Site Automatic Tunneling Addressing Protocol. The Web Proxy Automatic Discovery Protocol is used by web browsers to locate configuration settings to use a proxy server. For example, the proxy features of ISA server. The browser will locate the web proxy server by querying the DHCP server for the URL of the web proxy server on the network. So I could configure a host on the network with a host name of wpad.winstructorlab.com, and when my other clients on the network try to locate the wpad server, they'll be directed to my computer where I could issue them with a bogus configuration setting to force them to use a proxy server that I've set up and then divert their web browser to a malicious website. And all of this would be relatively easy as long as we don't already have a wpad computer already defined in our DNS zone. So when a client needs to locate a wpad server, it'll attempt to contact a host on its local domain using the URL of wpad.winstructorlab.com/wpad.dat. However, if we had a client in a different domain called client1.london.uk.winstructorlab.com, it's then going to attempt all of these URLs until it finds the appropriate server. Now, if it does locate the wpad.dat file, the client's browser will read the contents of that file and then configure itself according to the settings that's contained in the file. And that's where the problem lies. Like I said, I could easily configure a host and call it wpad, and then start configuring users' browsers with bogus settings to force them to a site of my choice. But I will remind you that if there is already a host called wpad, then that's going to prevent me from creating another one. The other protocol you'll need to know about is the intrasite automatic tunnel addressing protocol, which is a protocol used to transition from IPv4 networks to IPv6 networks. Basically, it takes an IPv6 packet and tacks on an IPv4 header to allow packets to be transmitted through an ISATAP router to an ISATAP host. Again, like with our wpad entry, a malicious user can spoof an ISATAP router by registering their host name with the ISATAP name. So how can we prevent all of this from happening? Well, if you're running a Windows 2008 DNS server, you'll be pleased to learn that you're already protected from this happening. The global query Blocklist is already equipped and configured by default to deal with this problem. So if we go and open up a command prompt, and we'll enter in DNS command /info, and then we're going to add in the global query Blocklist switch, and we'll hit enter. And in the output here, we can see that wpad and ISATAP are both being blocked by default. So what does this mean? Well, it means that by default, when a client attempts to register itself with DNS using either wpad or ISATAP as the host name, it'll be rejected by DNS, and that's great, so we don't have to do anything. Now that is unless we really do want to create a real host with this name. Now if that's the case, let's say you might be deploying ISA server for example, and we want to create a real wpad entry, then you'll need to go ahead and delete wpad from this list. So to do that, we'll rerun our last command here, and I'm just going to scroll across and change info, and we'll change that switch to config, and then we'll add in the host names that we want to include in this list. So here, since we want to take wpad out of the list, as we want to create a legitimate wpad server, we'll need to redefine the list of names that we want to block. So we'll enter in ISATAP, and we'll hit enter. Now if we rerun our original command again, you can see that we only have one legitimate entry, and that's for ISATAP. So now we can go ahead and register our legitimate wpad server on the network, and the global query block list won't block us from doing it. Now if you also want to block other host names from being registered, you could use this tool to do it as well. So let's say you plan on installing an Exchange server and you want to call it mail. Well, if we rerun our command again, and at the end we'll add in the host name of mail and we'll hit enter, and now we'll rerun our original command again. Now you can see that we'll be protecting the host name of mail from being registered in DNS as well. So this tool goes beyond just protecting wpad and ISATAP. You could use it for any host name that you like. Now, if you decide that you don't want any entries in the global block list, we could rerun the same command again, but just leave off any host names. and that's going to clear the list entirely. But you can also disable the global block list function if you prefer to do that by rerunning our config command here and then changing our last switch here, global query block list, to enable global query block list, and we'll set it to 0, and that's to disable it, or we can set it back to a 1 if we want to enable it if we've already disabled it. In this video, we've talked about things you can do to secure your DNS server, which will limit the exposure of your company's DNS infrastructure to the internet. We've covered the use of read-only domain controllers and using a server core build of Windows 2008, both of which will improve security and reduce the attack surface of your DNS server. We also looked at configuring secure dynamic updates, which only lets domain computers update DNS, as well as configuring zone transfers to only occur with other domain controllers that have been specifically listed or on the name servers tab, so that way you have control over which servers are allowed to get a copy of your zone files. Then we covered disabling recursion, we talked about non-authoritative resource records and configuring root hints, all of which can further lock down your DNS server to prevent undesirable circumstances from occurring. And finally, we've talked about the global query block list, which is turned on by default, and saw how it prevents rogue computers from registering specific host names in DNS. We hope you've enjoyed this video and would like to thank you for supporting Winstructor.